All right, this is the second part of our Adjusting to Reality PowerPoint. A friendly reminder, you have to start with a balanced chemical equation. If you don't, things are likely to be gibbled. So we're going to do 2 sample questions in this video, and they should be in the PowerPoint. Spectacular. Balanced chemical equation is your friend. So this is something called propane. It's being burned, making CO2 and H2O. And we're going to look at it from the point of view of moles. We have 3 moles here and 10 moles here. And we want to know what limiting and excess are. Some of you will be very sharp and have no problem with that. Some of you will find it difficult, but the nice thing is if you mess up, all it means if you get limiting and excess backwards, start again and declare things the other way around, and it should be okay. What we see is we need a 5-to-1 ratio of oxygen to propane. If I take 3 multiplied by 5, I see it's going to be 15. But I don't have 15 moles of oxygen. I only have 10. So this is going to be limiting. So I write LIM for limiting. Automatically, that makes this excess. So here's our clever way of saying excess. That's an X, supposed to be an X, that's an S. Now, looked at another way, if I take 10, multiply by 1, divide by 5, net effect divided by 5, I only use up 2 moles of the propane. So either way, we can tell the propane should be limiting. Sorry, excess, hello. So our moles reacted are 2 moles of propane, and we're saying that all of the oxygen is going to be gone. So now we just subtract 10 minus 10 is 0. That makes sense. No limiting left. And we have some excess left over. So there's how we say moles in excess in chemistry land. And we have 1 mole of propane left over. And we can see that if we go 2 times 3 over 1, we're going to get 6 moles of that. And 2 times 4 is 8 divided by 1, so 8 moles of that. So if we're asked for the amount of product, those will be the theoretical yields in moles of carbon dioxide and water. Of course, that water and carbon dioxide will both be gaseous. So that was an example where we just looked at land and mole. You won't get many questions like that. Most will be like the next one. So here we have a volume and concentration, and we've got some copper, we've got a mass of it, and we know, hey, we need a balanced chemical equation. So we need to know limiting reactant, excess, theoretical yield, all kinds of stuff going on here. So let's see how we get on. There's our balanced chemical equation. And I just call this actual mass. I know this is volume and concentration, but this is just telling me what's supplied in the question. Well, if I have volume and concentration, I can easily get the moles of silver nitrate. And I've got mass, so I divide by molar mass and I get the moles there. Now I need to have twice as much silver nitrate as copper. And I don't have twice as much. So I know silver nitrate is going to get completely used up. And I know I'm going to have some leftover copper. So once I declare that, then I know all of the silver nitrate is going to be gone. I use my mole ratio. I multiply by 1 over 2. So there's a 1, 2. And I get 0.200 moles. Now I can subtract actual minus the moles reacted. And there's my moles in excess. Limiting always has to go to 0. And then when I'm trying to calculate my product, I think it was after silver, I can't remember, I'm going to use my limiting moles. Reason I don't want to use this mole, if these happen to be correct, but if I messed up here, then I have no chance of getting it right. If I messed up on limiting on the excess, I still have a shot at getting it right. Now, how did I get the 67.3 grams? I just took my 1.06 and multiplied by the molar mass of copper. My theoretical yield of silver, well, 0.4, it's a 2 to 2 ratio. So right here, I would have my 0.40 moles right there, beautifully written. And I multiply by the molar mass of silver, and that gets me my 43.1 grams. That's what I'm doing there. So hopefully that makes sense. Follow the steps. It does take practice. Some of you will just dominate it. Some of you will take some time to get there, but you should be able to get it fairly quickly.